So welcome to the Inside Spring IO presentation this morning. So we're going to talk about the Spring IO website, but especially Spring.io website, but especially the application that powers the Spring.io website. So first, last year at SpringOne, if you were there, Chris Beams presented the new Spring.io website during a session like this. And he'd been working on that application for months before that. And he also actually pushed the application to production during the main keynote, which was very, very brave. I'm not doing something as brave as that today. And so it's been a year, and we're going to talk about this new Spring.io website, and with that year in mind, what we've done and all that. But first, also, if you know Carl Sagan, maybe. Carl Sagan, he was a famous astronomer, astrophysicist, a cosmologist. And he made many contributions to his field, and some of them were central to many discoveries about the universe. But he was also an author. He wrote books, and including Contacts. He was interested in many things, including other forms of life in the universe. And also, he worked on making astrophysics popular. And because he thought that both the public and the science would benefit from that relationship. So why are we talking about Carl Sagan this morning? Because we named the Spring-based application that powers the Spring.io website, we named that application Sagan. Because we'd like to explain many of the wonderful things that Spring has to offer. And we'd like you to get value out of it. And we hope that our little project might live up in some small way to its very big namesake. So we'd like you to get value out of that application, and we'll also like to learn from you while this. So now that's me. No, not me. So now that's me. I'm Brian. I'm a Spring Framework committer. I've been committer for a year now. And I'm especially focusing on web and messaging technologies in the framework. And I've also been a Sagan developer for a year now. And during this presentation, I'd like to walk you through what happened during this year. And hopefully, you'll get something interesting from it. And we can discuss many aspects of that presentation during the Q&A section. OK, now the plan. So 3 things happened this year with Sagan. The first one was that we open sourced the application, and we had to do several things while open sourcing the application about the code base, the tools we used, the way we organized. And we also evolved the application within its code and the way we deploy that application. So we worked a lot on the upside. We started with manual deploys, and then we ended up today with something automated and very, very good in my books. And but with the last part, one might say we're done with that application, but we're not. We've still got a lot of things to do with Sagan, and it's a living web app. It's in production right now. And we found out some issues this year and while looking at it and how it behaved in production. And I thought I might share that with you during this presentation. So open sourcing Spring IO. So why didn't we open source Sagan in the first place? Because we've got example and sample apps everywhere in the Spring portfolio. But those examples they're neat because you can learn things about a specific project in the portfolio, but enough sometimes because you don't have enough features or enough constraints, and that's definitely not what you have yourself when you're working on an app. So maybe a reference app, but reference apps, they're nice because they have more features, more trade-offs, more constraints. But then you can always ask, would you use it yourself? I mean, Spring Team, would you use it that way? Or does that reference app scale? Is it production ready? Those questions, they're legitimate questions. So when Pivotal chose to invest even more in the Spring portfolio, we wanted to send this message to the community, have a new Spring.io website, but also we started to rebuild that website from scratch, and we wanted to have that as a reference application and running in production and always live. So if you don't know the Spring.io website, it looks like this. That's the homepage, of course. It's got a blog where you can read all the blog posts that the team writes. It's got a portfolio page where you can see all the projects. It's got guides. So the guides are small tutorials you can complete in 10 to 15 minutes on a particular topic, and that's really helpful for that particular topic. And you can search for things within the website. So obviously, it's got a lot of visitors, and we chose to build it on top of Spring 4, Spring Boot, an embedded Tomcat, and it's running in PWS, Pivotal Web Services, hosted on Cloud Foundry PWS. And it's been like this for over a year now, so we've got some feedback to share. So why did we actually open source Sagan? How did we do it, actually? First, we made the repository public. So it was a private repository before, but you still got the whole Git commit history behind it to see what we did before. So it's a public repository now. We chose a liberal license for you to reuse that code however you want. It's a BSD3 license. And we're also committed to being fully transparent. So everything that's published on the master branch, it's the actual code that's running in production right now. So whatever you see on the master branch, that's what's actually. So if you see a security issue, just send us an email, because that's what's going on in production. So if you take a look at the project layout, here's an overview. So you get the main Sagan project. You got several modules. There's the Sagan indexer, which is a separate microservice we use to index the website live in production. And we write that to an index, and that's what powers the search behind the curtains. So that we're using Elasticsearch for the search. So that one. We've got Common, Sagan Common, which is a common module with different services and models. We've got the Sagan side, which is the main web application. That's what we push to production, and that's what you see when you type spring.io in your browser. And we've got also a sagan-client module. And that module, we'll talk a bit more about it, but it's a separate module for the client side of the spring.io website, the Sagan app. So that year, we wanted to share also what we did and how we did it. So we wrote several blog posts. You can check them online. I'm not going to repeat the content here because it's already available online. But we did explain our work and motivations along the way and the problems we faced. So there are really a couple of them that are really interesting there about the deployments, the client-side architecture. We'll maybe talk about it later. And we tried also to write really nice embedded documentation, because documentation is vital for an open source application project. So we wrote guides in the GitHub wiki. You can check them out. So that's where you can see how to install the application, run it locally, run it in production on Cloud Foundry, etc. We're sharing a lot of things here. And we've added also comments everywhere, and we're in the process of adding more READMEs everywhere, because I don't know about you, but when I'm discovering a new project on GitHub, I like to browse the project and actually get a feel from the code base and see what's going on. So for us, adding READMEs at specific places should be a nice way to guide you through the application and see what's going on. And we did rewrite, we partially and totally rewrote some parts. So, obviously, and we just wanted also to make improvements. So in those rewrites, we had the JDK8 feature, so that was new. When we switched to JDK8, we could rewrite and simplify our code base with the new JDK8 syntax in many places. That was nice. And we also reorganized our code architecture because we thought that that would be easier to read and easier to understand. And we also ran analysis tools on our code base like Structure 101 or the IDE tools you get from your IDE. And we fixed a lot of, obviously, package cycles and readability issues, etc. And we also tried to have the best getting started experience for that application. Starting from the clone command to running locally, we wanted to have the best experience possible. But we still have a lot to do. So we've got issues from actual people from our team saying that the getting started experience is not there yet. So we're still working on it. An important thing also is that with the help of our colleagues John Han and Brian Cavalier, we revisited the client-side architecture of our app. And we modularized that client-side, and we set up a new build toolchain. That's a really interesting thing because we all learned something from that. Like I told you, Sagan is not technically a single-page app, but we're still relying on JavaScript for many features. And because the client application has its own dependencies and tests and build system, we chose to give it its own module and not hide its sources under SRC main web app. That's where you usually find the static resources like JavaScript, CSS, usually find those under SRC main web app. But while working with our colleagues and while seeing what we were doing, we thought that separating that into a separate module, the sagan-client module actually, we thought that would be a better experience for the JavaScript developers, for us, for everybody, separation of concerns, everything. So we'll talk about it now, why and how did we do it. So first, you might wonder, how can you integrate and work things out with a separate client module? How can you do that? One of the motivations behind all this is that we wanted to use the best tools available for our client-side application. So those tools are usually, if it's a JavaScript application, those tools are usually, I don't know, Node, all those tools. So we didn't want to have a subpar experience with other tools that integrate well or not that well with the build system we were using. And we really wanted to have the best experience out there for that. So that's why we created a separate module with all that. And we tried to integrate all that nicely with our Gradle build. So in that module, we've got a build a Gradle file. And integrating all that was quite easy, actually. Because if you look at that, when you were working with a client application written with in JavaScript and using Node and all those tools, you usually run commands and you're using the output of those commands and just packaging those, etc. So we were doing this within Gradle. So if you look at, we've created a task npm install. And that task is actually running npm install on the command line. But we've added a couple of things with Gradle because we're using the inputs and outputs of Gradle. So that task is only running when the inputs changed. So when you rerun the task, if nothing changed on the client side, it's up to date, doesn't do anything. So our inputs here for npm install would be our build descriptors. So package.json, bower.json, that's where our dependencies and our main build, one of the build system lives. And the outputs would be the node modules directory. That's kind of the target, something for Maven. And we've got another command, which is the npm build. That's the main one that depends on the install. And in that one, we're just running an npm script, and we're running our build, which is a Gulp build. So we've got the descriptor, which is the Gulp file, and input outputs, same thing. So once we have everything under a target or here a dist directory, or everything our client, when we have our application ready, our client application ready, we want to do something with it. And how do we integrate that into the Sagan site web app, the classic web app? So the output of that module is a web jar. It's actually a jar where we stuff all the optimized resources, all the output of that build. And in fact, here it's a good idea to enforce separation of concerns. We've got a client build, server build, different things. And Gradle is really helpful here because we've still got the input-outputs things, and it's easy to deal with the log levels and etc. So issuing commands, I mean, Gradle issues our those commands, those npm commands, but it's not that a big deal. It can integrate nicely. If there's an error, it shows up quite nicely. So here we are taking everything from the dist directory and creating a jar file. And that jar file is a dependency in our main sagan-client module. So that's how it works. We just have a jar dependency, and we've got our client build. So the sagan-client application, I mean the module sagan-client, doesn't really know about how the sagan-client is built, and it doesn't matter actually. So we do have like I told you, it's not Sagan is not a single-page app, but we're using a lot of JavaScript. So we decided to create a modular JavaScript application because when you're used to things on the Java side, going on JavaScript without modules, without dependencies, without a build system, it's really painful. And all those things, they exist today in JavaScript. So we're using here curl, which is a JavaScript module loader, and to achieve to modularize the application. So just like you wouldn't create a Java project without structuring your code, we're doing that on the JavaScript side. I really encourage you to look at those things. There's a blog post that I listed before. One of those is explaining the JavaScript modularization, and that's really one thing to check out. So here we're just describing actually our main packages, where our dependencies live, and we are launching our application. And then the module loader knows how to load those module dependencies, etc. So that's one way of having a nice modular application. And as a build system, so what would be Gradle or Maven on the client side? We're using Gulp, which is a streaming build system. Even though we started with another build system that is Grunt, and we were quite happy with that one, but I had some trouble organizing my build, and I didn't like the way things read. So I tried Gulp, and I was quite happy with it. So that's really a personal preference. And maybe, in a way, because Grunt is more declarative, I'd say, and maybe like Maven, and because I kind of like Gradle a bit more, then maybe that's why I chose Gulp, because there's a different ratio between declarative and imperative, so that's why probably the preference came from. And it's called the streaming build system because it's based on a simple yet powerful concept that's Node.js streams, and that's kind of like the JDK streams, but we'll talk about that now. So from our gulp file.js file, there's an example. You define tasks, and since we're using streams, it's very I/O efficient. It's not using temporary directories along the way for each task. It's reading files, applying changes on the fly, and then writing the output once. So that streaming concept, it forces plugin developers to be really consistent and concise, but at the same time, it forces you to be really consistent within your own build. So here we've got a minify CSS task, and we're just saying read all the CSS files from that directory, and then pipe that just like you'd pipe that into a bash command, and pipe those files into the CSSmin function that minifies all the CSS files, and then pipe that to a destination directory, and that's written. So the second step, it's happening on the fly. Nothing's written on disk. And you can run those tasks in parallel. So the last line, you can see that we're starting the build, and you've got several tasks, and all the tasks that are in that array, they're executed in parallel. But there are some downsides to that approach. First, I'd say Gulp developers, they're trying to maintain a selection of Gulp plugins to avoid duplicates, but it can be hard when everything in the JavaScript world is moving. And for them to, I'd say, to choose and maintain that list. Another downside would be that the streaming mode has some limits. In my examples, it looks nice, but in this one, to me, it's not that good because here we're using a special plugin, which is source maps, that creates source maps for your JavaScript minified files. Because when you're in production and you want to debug something in JavaScript, if you're trying to debug the optimized version of the file, then you're lost. But if you have source maps, then it helps your browser to show you the right names, the right names of variables, and not the minified version. So you definitely want that in production. But here in the streaming build system, you don't want to feed the source maps within the mainstream. You don't want to treat them as sources files. They're actually outputs of the build. So that's weird. You want to set them aside, and that's what we do actually. We get here we're cramming all our JavaScript files, concatenating all of them into a run.js file, and then we are creating source maps, but then we're setting them aside of the stream. We are uglifying the main files, so they're minified, and then we're bringing back those source maps into the mix, and then we're writing everything to disk. And you see that approach, it's kind of weird to think in streams and then setting things aside and bringing them back at some point. That's weird. Sometimes I wish that abstraction was not just streams, but maybe a tree of files or something like this. So yeah, it works, but that approach has some downsides. One good thing about open sourcing also the Spring.io Sagan application is that we use Sagan now to experiment, collaborate with our other teams in the portfolio teams, and even drive our decision on the Spring projects. So for example, Sagan played an important part in our new resource handling feature in Spring 4.1. If you want to know more about that resource handling feature, we've got a presentation tomorrow morning with Rossen. And so I'll talk a bit more about the client side and the server side and how do we manage to to handle our resources more efficiently for modern applications using JavaScript and others. So that was a real experience that really helped us in the framework and other projects. And another good thing that happened with open sourcing and pushing Sagan in production and using it for a year is that besides serving its primary purpose, which is being the Spring.io website, Sagan does also many things for our teams. For example, Sagan is a Spring Boot application, and it's been running in production for a year. So the Spring Boot team and the framework team, we're using Sagan as a canary application. So before releasing a new version, we're always trying our example apps, but we're also using that one. So that's another way of validating our project before the releases. So now, how did we? So Sagan now has been open sourced. It's in production, but how is it like to maintain the application, the code base, to run in production? What kind of issues we had? What are the strengths and weaknesses of Sagan in that way? So this year, as I told you, we migrated the application to JDK 8, and we managed to simplify a lot of things. And we made our code look more functional, like this, actually. And only where needed to, of course. But full migration is not done yet, because those kind of, I'd say, structure can be done quite easily with your IDE. Some IDEs, they help you to migrate your application and just tell you that you can write this that way. Instead of using that structure, you can use the stream approach here to instead of going through all the project releases and then selecting only the ones that fits, etc. So you can do that. But we're not done yet with JDK because we have still the datetime API to use them everywhere in the Sagan application, and that's a bit harder because it's everywhere. So it's in your model, it's in your entities, it's in your template engine. So it's kind of hard to have a consistent approach everywhere. So we're still working on it. We have PRs, but that's a bigger challenge for me. Also, how did we manage to evolve the application quite easily this year? So along the Spring Boot releases, we used more and more the enable auto configuration and all the auto configuration features of Boot in Sagan. So for example, this one, the enable auto configuration, it tells Boot to guess how you will want to configure your Spring app based on the jar dependencies you have and the configuration you have in your app. So for example, if you have a Spring MVC and Tomcat and a Tomcat jar on the class path, then it tries to guess, configure, and set up Tomcat as an embedded server. So it does a lot of things for you. So you can do the same thing. I mean, the same thing applies for, I don't know, messaging, persistence, batch queues, etc. It's a lot of things exist in that space. But the thing I liked is that whenever we need to do something special with Sagan, because you always want to do something special with your application, if you can partially deactivate that auto configuration. So if you don't want to auto configure the MVC space, you can just say auto configure everything, but don't auto configure the MVC part of my application. Or if you define your own beans, for example, then Spring Boot backs off and lets you do the right thing for your application. So the auto configuration is not pure magic that will hide you things from you. It's just helping you when you need it, and it just backs off when you don't want to. So how does it work, creating beans on some complex conditions? How does Boot does that? So that brings us to Spring 4. And Spring Boot is using a lot the add conditional annotation. So you may use that in your application as well, but Boot is already doing a lot of work. But that's an important feature in Spring 4. And instead of juggling with configuration files and properties, you can now register beans and configuration classes under certain conditions. And those conditions can be an environment variable, or some things on path, or a class is present or not, a lot of things. And that can be the cornerstone of your configuration application. Of your application configuration. And many Spring Boot features derive from this. So here we're, for example, saying that that configuration class should only be applied when that particular custom condition is met. And that class can be whatever, just checking that one class is on the class path, or many other things. That's really, really interesting. And we actually rewrote our own profile annotation, and it's doing this right now. So you can use that to derive your own annotations and be more flexible. Another very useful feature for the upside of Sagan is that we are using the Spring Boot actuators. So we added a starter in our build file, and we get very, very useful endpoints for free. So, for example, we've got info, the autoconfig, health, etc. So you get information from your application live in production. Some of them are protected, obviously, but some of them are actually working. Some of them don't need authorization. I'd say info and health, you can access that from your mobile if you want to in production with that URL. So the nice thing about that is that whenever something goes wrong with Sagan, I just curl those endpoints, and I get instant information about what's going on. So it can be traces, it can be what kind of beans are registered, or what did the auto configuration with Boot, all that. And you can also add, for example, for the health endpoint, you can add your own checks. and check that an external system, maybe a web service you're calling, is up or not. So you can add a lot of things there. And with a single request, you can check that how's your application doing. And if you need even more, there's another startup that's really useful. I tried it with Sagan, but it's not up now, but I'll probably add it soon. You can add a remote shell that uses crash under the covers. And this one is really nice because that's actually what you get from SSHing into your application. You can do that even in Cloud Foundry. You just SSH into your app. And that way, that gives you the kind of information you expect from the htop command on Linux. So you get everything from threads to memory to CPU, etc. That's a really nice dashboard you can get from your application. And how did we manage to do all this during that year? So we are a distributed team, as you know. And team members that who shipped code in Sagan this year include the cities, Vienna, Clarksville, Kansas City, San Francisco, London, Pittsburgh, Boston, me in France. And how do we manage to get even work done, and how do we organize to work part-time or full-time on an application and get stuff done, even working remotely? So we use a lot of tools. And one of those is HipChat. I really like that one. And so there's a Sagan room in our HipChat instance. And in that room, we set up integrations with GitHub and Travis and all that. And if you want to know what's happening with Sagan and you want to work with Sagan, then a team member can come into that room and see what's going on, talk to the others, and see what's been done during the night, because we're obviously not all on the same time zone. And one thing, we're extensively using GitHub issues, because we thought that would be the most easiest way to interact with other developers. But then it's sometimes hard to organize your work. So we're using Waffle, which is a nice service where you can organize your tasks. And if you're doing something like Agile or GTD or things like that, it's really useful to organize your work. And this year, we also really did embrace the continuous deployment. So from the first deployment live that happened last year, which was using Gradle, but we did the deploy manually, today we are using a fully automated deployment. So whenever something is merged into master, then it's picked up by the Travis CI, and it's built live, and it's automatically pushed to production. So we went from doing things manually to not doing things anymore. So whenever something gets merged in master, it's pushed to production if the tests obviously are okay. So we can safely say that now we deployed more than 100 times in the last 3 months. So yeah, that would be one deploy a day. So some days more, some days less. But still, we automated things, and we used the Gradle Cloud Foundry plugin to do the green-blue deployment. So right now, we don't have a lot of cruft into our Gradle build files. It's part of the Cloud Foundry plugin. So the green-blue deploy there. We used a lot of new features in the Cloud Foundry Java build pack to auto-detect everything we use. And we used also, as you can see, we use the Travis CI service. So you might wonder, how do you deploy to production with a public service like that? There's a way to hide specific values like passwords and all that into your build, so it's not visible from the public. But you can still deploy automatically your application to production. So a bit about the green-blue deployments. It's been well described in one of Martin Fowler's posts and many other books. But in a nutshell, you just have two copies of the same application running in production, the blue one, the green one. and you route all your traffic to one of both. And whenever you want to deploy a new version of your app, you just, here we deploy the new version to green and check that, it's deployed to green. And then when you actually flip the switch, you just reroute all traffic to the green one and just unmap all traffic from the blue one. So you do have two copies of the same application running in production, but then when you're on Cloud Foundry, you can scale and unscale one or the other. So that's quite easy, and you're not wasting money having too much servers. So that works out well. And this all works out because there's the Cloud Foundry router. That one is written in Golang, I think, and it gives you full control over the connections, so it supports WebSockets and all that. So that way we are not losing traffic when we're flipping the switch. We're just mapping to green and unmapping to blue, so we're not losing requests when we're doing that. So one of the blog posts I mentioned earlier, it's talking a bit more about that. But then we discussed with many people about that green-blue deployment after the blog post, and we had many questions about it. How do you do session management? So by default, the router, CF router I showed you, is enforcing sticky sessions. So that's one way of doing things, always routing the same sessions to the same instance of the application. Within the green application, you get several instances, always routing the request to the right instance. But it also means that when that instance dies, the session are gone as well. So there are other ways to do that. So you can, in the Java build pack, you can use, there are ways to easily do session replication with Redis. So you get the session shared within your instances, or you just don't do sessions. That's maybe the better way to do that. We also had questions about how do you handle schema updates in your database. So we do have a SQL database with Sagan, a marketplace service in PWS, and we're using the FlyWayDB tool to do that. So we have migration scripts that run in order, and whenever we want to do something and update the schema of our database, we just add a new script, and we can test that on the staging instance if we're not really confident about it. But once we're confident about it, we just push that to production, and it updates the database live, and it works pretty well until now. But there are many other solutions out there. This one works well for Sagan because we don't have huge needs for our database. We're not changing the schema every day. But there are other ways, like what I call the divide and conquer. You can just try to have several schemas, or just try to have some kind of read-only flags in your application. That way you can just set one part of your app and some features to read-only, and just update the schema and do something else, and then just go back to write. Or you just, if you have really specific needs with your database, then maybe it's time to choose another database store that fits your needs. So maybe a document-based data store or something like that. But that's an interesting question when you're trying to do green-blue. And the general advice on that would be to use to take a look at the 12factor.net website, which has a lot of advice on how to build an application to run smoothly in production. So there are a lot of advice on how to maintain your code base, dependencies, and how to write your config, and concurrency with your app, and all that. So there are a lot of really nice things that we looked at while working on Sagan. So now Sagan is quite stable. We've got many issues to address still. But we didn't cover one aspect yet, which is how does Sagan behave in production? And that's really something. You can take a look at the code, but you don't know how it runs in production. So I'm going to walk you through that process because I did that this year. So first, here's a short diagram of what is the architecture of Sagan, actually. So requests coming into the Sagan site application running on Cloud Foundry. And we've got a marketplace service, which is a SQL database. And we are calling external services such as our Elasticsearch instance for search requests. And we are also getting a lot of things from GitHub because we are getting we are rendering our blog post using the Markdown service from GitHub, but we are also getting our guides from there. So the guides, like this, are actually that. They're asciidoctor documents, and they're into a public, open GitHub repository in the Spring Guides organization. So you can send PRs and check that out if you want to. And they're written in the asciidoctor format so that it's easier to maintain for us. And so we are actually, Sagan is actually fetching them from GitHub and rendering them to HTML within the application. So the app is, like I told you, is using several marketplace services. It's using our database, and it's using as well a new Relic service. So we had that service, and I thought, I just wanted to try to use that one, and including also the actuators and all that to get a look at what happens in production. So I didn't have much to do to get the agent running. That's a good one because the build pack is doing that for me. So the agent is started whenever you start the application. That's an actual, those are log lines from the Travis CI build log. And it's doing the right thing and mapping on the right instance, green, blue, etc. So whenever the first time I looked at the dashboard, I saw all that information, and the thing depending on your application and what you're trying to achieve, there are many ways to interpret those. It's always like that whenever you look at graphs, and but I'm going to be really transparent about what I found out and whatever I think. So there may be just things that are wrong, but you'll tell me. First, I found out that my first diagram was really crap, and this one is actually better. And because I didn't configure anything special, I got that one. So you can see the Sagan app, and then the external systems we're actually calling. And what I didn't know was the actual the number of requests that actually went to each external system. So I really knew which one was more heavily used than the others. And you can actually see live the number of requests. So I took a good look at that one, and that gave me a good first start. And then I took a look at the error rate, which was quite low, but still there were some of them. So when looking at the actual errors, I saw that many of them were actually 404s that were not handled properly within Sagan. So still some work to do because some 404s translate to exceptions instead of nice missing page, a 404 page. So there shouldn't be exceptions there. So the nice thing is whenever I look at those errors, I can see which URL is triggering that exception, and I can try to fix the problem behind all that. And then I took a look at the top transactions that are being done with the Sagan application. And whenever I try to profile an application, I always find useful to start picturing the results before actually checking them, because it makes ask yourself, where are the bottlenecks? Where do you think they are? What's the biggest latency problem probably, or is it the biggest problem, latency? And what are the most used endpoints? And with that, it shows that the top web transaction for Sagan. And a few weeks ago, actually, this diagram didn't look like that at all. Because what I found out was that the #1 transaction for Sagan was our Atom feed. So I was quite surprised. I knew that a lot of people some people are still using RSS somewhere, but I was quite surprised by the sheer number of those requests. And when when I took a look at the actual log in production live, depending on the hour, the time of the day, they were hundreds and hundreds per second. So maybe some people are writing scripts or something like this. The thing is, it's not really giving a lot of value just serving the same thing over and over, because on top of that, those Atom feeds don't change a lot, maybe once or twice a day, but not more. So we do have a CDN with our application. We're using that to serve our static resources. And I added a page rule to just use cache on that particular resource. And that way, I'm still using, the CDN is using the actual cache headers I'm sending from Sagan. But I've set up within the CDN settings, I've set up that those resources should be cached in the edge cache of the CDN, should be cached longer. So right now, instead of having hundreds and hundreds per minute, I just get 1 or 2 requests every 30 minutes for that one. But still, we're getting a lot of traffic on the CDN side. So that way, I had a better picture of what happened in production. And I managed to scale down a bit the application because a lot of resources were wasted like that. So now that I had a better view what was happening, like here in the top transactions. So I saw that there were searches, guides, etc. So that's the clearer picture. But then I thought, are we losing time, or are we having something that's not efficient within Sagan? So I tried to profile the threads. And I launched several sessions, depending on the time of day. And the profiler didn't really mess up with the application, so that went well. And the first thing I found was that we spent a lot of time in our templating engine. And I didn't know why. And it shouldn't be like that in production. So that first profiling session uncovered a simple yet serious typo in our application configuration. And because we were disabling template caching for all profiles instead of just development. So that happens. And after that first fix, things were more clear in the other profiling sessions. Because that was the fix. The application.yaml file you can write with the Spring Boot, that can be misleading sometimes because when you're used to something else like XML or something else, it's easy to get the wrong copy and paste, or when you're trying to reorganize your profiles within your YAML, and that's what happened. We reorganized our profiles because we wanted the default one to be the default experience you get when you run the application. And with that, we left the disable cache in the main profile instead of putting this into the development profile. So a lot of resources wasted for that, but it's fixed. And then I went to monitoring transactions to get a little more information from there, and how our resources are spent and what's going on. And I saw that each transaction is mapped to an actual controller and its action. So I thought that I saw the highest throughput. I saw what's the most time consuming, where's the worst average response time and all that. And that's where I picked my candidates for optimization. And what I found out is that we lost a lot of time in search transactions. And we are here, if you see the purple part of the graph is actually the part we spent into the HTTP client. So we are waiting for the response to come back. So big latency issue with our Elasticsearch instance. One problem. And then when I saw the external the external service panel, then that was more clear. I saw that depending on the time of day and depending on many things, I could get like more than 1 second of latency sometimes. So when there are not a lot of searches, that goes well, but when there are many searches, it's really bad. So that's one problem we should look into. And I looked at the Spring Guides transactions and how they looked. And I saw that we spent also a lot of time actually rendering the guides when those guides don't change a lot, actually. So why are we doing that? And they are actually refetched often from GitHub. And we have a cache TTL that may be too low. So we end up downloading and rendering and downloading and re-rendering the guides. And that's being done way too often. So we need to do something like this, like this here. So with those problems, I thought about several improvements. They're not done yet, but I'm working on it. So first, we're using another server for our Elasticsearch instance. And maybe we didn't configure something well with our server, or maybe there are some latency issues with the network where it's hosted. So the thing I'd like to try is to use a marketplace service and try the free tier or whatever, and see if the latency issue is still there. Because I think it will fix the problem, actually. So that would, and moving that to a marketplace service should help us have less sysadmin work and probably improve reliability in that way, and save us money because running your own server and using a marketplace service is obviously less costly. About the cache strategy, the guides problem we have. Then that's probably the way we handle cache that's probably totally wrong. So we have concurrent cache maps on each instance of the application, and the TTL is way too low. And it's not really in sync, because whenever the guide is updated, we want it to be updated on the site right away, because whenever we are releasing a new version of the framework or another project, when we want to update those, and we want it to be updated as soon as possible. So for that, also I'll try to use another marketplace service to use Redis as a shared cache, and maybe refine the TTL strategy and how cache expires. So that way, I thought that since guides are actual repositories in GitHub, there are ways to create specific hooks. So whenever something happens in the repository, you can ask GitHub to trigger a request to something else. Maybe it may be like HipChat or whatever, an external service, but it may be your server as well. So that way, I thought that whenever someone pushes code to one of the guides, Sagan should be updated, and all the cache for that particular guide should be evicted. So that way, we are caching, our TTLs can be way, way longer, and we are evicting the cache whenever it needs to. So with all that, the open sourcing, what we did on the client side, and all that, I had several thoughts that I wanted to share before we head to the Q&A. So what I've learned is that with smaller distributed teams, the time I spent managing the issues is really, really important, because I find myself spending a lot of time in that waffle screen, just looking at issues and sorting them, and that's usually really useful, because I get a full picture and I can get my priorities right. So that one is really important, and that the contributor and developer experience is a top priority. Because we're using the sagan-client application, we have some constraints, like requirements to run the application. You need NPM, and you need Node, etc. So the getting started experience is really, really important. So, for example, we had issues with people running on Windows, or some people had issues on their operating system, and that didn't go well with Node or something else, or the way Node was installed. So all that we have to take care of. And I learned that whenever I looked at monitoring and the profiling of the application, I always learned something. Whenever I looked at a graph, even if I looked at the week before, I always get something from it. So that's something now I look at more and more. And in cloud environments this year, you can always throw more resources at problems. But then when you take a look at it, or use maybe external services or something else, you can actually scale better and save money. So that's what I'm actually trying to do right now with all those fixes I told you about. And I already downscaled, I eliminated one instance from Sagan, and it's running smoothly because of the CDN and the first improvements I did. And if you had one thing to remember from that presentation also is that, okay, Sagan is a reference app, but it's also an open source project. You can contribute, ask questions in the issues. We can talk about it. And it's more importantly, it's a JDK8 Spring 4 Spring Boot application, critical, running in production with a lot of traffic. So whenever you want to convince some people to use this or that, like real examples of running applications with critical, that are critical and with real requirements, that's the best way to do that. And I really hope that Sagan can be one for you. So we have a lot of time for Q&A. So, do you have questions? Do you want to talk about some things we discussed during the presentation? I went a little bit fast, but I thought we would like to talk about things. Yeah. Yeah.
That you basically choose which one, where it's deployed. Is that all part of the continuous deployment? Does it automatically choose green or blue?
Okay. So the question was, when you're doing green-blue deployment, how do you choose green or blue, and is it done automatically or not? So yeah, whenever, if you look at the spring.io/info endpoint, you can see the actual commit SHA that is running in production, and you can also see the variant running. So you can see Sagan blue or Sagan green, and you can even see, it usually says, for example, Sagan blue column 1. So that's Sagan blue instance number 1. And so you know which instance responded to your request and which variant it is. So the green-blue plugin, Cloud Foundry plugin, is actually checking live what instance is mapped to Spring.io, and so it's deploying to the other one and checking things, and then unmapping and mapping. So it's chosen automatically. So the only thing you can do is maybe if it's right now it's not done automatically by the Gradle plugin, but one thing you can do manually is then a rescale. Like if you don't want to waste resources because the version of the variant of the app that is not online, it has many instances. Maybe when the green-blue went well, you just want to scale down to 1 because scaling up is really fast, so you don't want to have servers sitting idly. So that's the one thing you could do manually. That's not done manually right now. Yeah. Okay, so the question is, because I said we are deploying the app with Travis automatically and pushing that up to production, the question was, don't you run manual tests? Because things can fail, and do things fail sometimes whenever, even those tests are green? So yeah, Travis is running all our tests for us. So it's first it's doing a Gradle build, checking all the tests are green. And if it is green, then it's running a Gradle deploy to deploy the application in production. So that's the first incentive, because when you know that you're doing continuous deployment, you get that nice feeling of not having to push to production all the time and doing all those tedious work. But then you have an incentive to write a lot of tests, and including integration tests and all that. And yeah, so that's an advantage. That's a good thing and a bad thing at the same time, because you have to write a lot of tests if you want to be confident when you push to production. So those tests are run automatically, but whenever there's something a bit tricky, like the database migration, the schema updates, it's really hard to write tests, and since it happens only once in productions, then I usually don't write tests for those. And that's when I deploy manually to our staging instance, and then when I check that the migration went well, that everything works well. So sometimes, depending on the change I made, sometimes I'm deploying manually to staging to check that everything went well. But the continuous deployment thing is nice, because you're tempted to have just to add little changes by little changes. And whenever I do something really big, I'm usually starting a new branch and deploying that branch to staging, and doing that work in parallel with other little changes I'm making on master. So times didn't check properly before. So yeah, we had issues like like you said, 404s, or things that didn't show properly locally, because for example, on the client side, whenever the optimization phase goes, and if you didn't check properly locally that the build went well, then yeah, so we had issues on the client side as well. So right now for Sagan, I've got I had 4, and right now we've got 3, because I downgraded to 3, and it looks well. But depending on the time of the day and the period, and the activity on the website, sometimes I'm scaling up, scaling down. It's one command, so it's just cf scale the name of the app and then the number of instances of the memory, and it takes like a few seconds. So I'm doing that a lot to try things out. Sorry? Yeah, right now we are using a concurrent cache map. So the question was, how do you manage the caches for each instance? So yeah, so right now we are using a plain dumb concurrent cache map. So that's just an in-memory cache for each instance. So it means that if one instance is writing to its cache, the others don't share that cache space as well. So that's one of the bad things with what we saw, because so every instance is checking the same guide from GitHub and rendering. So yeah, if we've got more instances, we've got more requests to GitHub, and more. Well, if we did need to have like maybe twice the number of instances, we'd have scaling problems. And I didn't show them, but there are ways to show in those graphs like scalability graphs that try to show you if your app would scale, depending on the number of requests, for example, the response time with the number of requests, or CPU, whenever your CPU is used more, does your app scale? And you've got other graphs that kind of tell you that you can see that there's clearly a bottleneck. If the number of requests per minute is more than that, then it's not going to. So yeah, the caching issue is a big one, because we definitely, even though we don't have a lot of instances, the TTL is maybe low also, but a shared cache should go really a long way. And maybe by sharing cache, we can downgrade another instance and only have 2. But that maybe would be dangerous, because sometimes we have big traffic spikes. Yeah.
I was just wondering, you mentioned how in Spring Boot you can choose to not use the autoconfiguration.
Yeah.
I was just wondering how often you might wait for autoconfiguration, or what situations.
Okay. So the question was boot. I mentioned that boot can back off from the autoconfig, and And so how often do we use really specific things and don't use the autoconfig? Actually, we used specific things, for example, for Flyway DB, because we needed to set it up specifically for our migration, for the migration, DB migration. And because we gave feedback to the team and because they get a lot to the boot team, when upgrading to another version of boot, I totally removed that part of my application because they added a specific autoconfig that does the Flyway DB support. So we removed a lot of things. So usually we started big, and more and more boot is adding features, the less code I have in the configuration space. So it's, I'd say it's going the right way for Sagan, at least. And I didn't find a lot of reasons to ask boot to back off. Like I only did that once, but not for Sagan, for another app, because I was testing specific things on the Spring MVC. And then I wanted to test one specific cases with MVC plus boot. Then I wanted to then totally ask boot to disable the autoconfig for MVC. So those are really specific cases, but I didn't really need for Sagan to ask boot to back off, because it does automatically whenever I add my own bean for I don't know for message converters, for example. If I add mine message converters, then boot doesn't add the default ones. So it backs off, but you don't have to tell it explicitly. You just do what you do it for yourself, and that it guesses the right thing. And that's my experience, at least so far. Yep.
Do you provide any visibility into your continuous deployment process?
Oh, OK. So the question is, do you provide visibility into your green-blue deployment and deployment process? So that's the. I don't know if we could be more transparent, actually, because whenever something is merged into master, you can go to travis-ci.org and select the Sagan project, and you can see all the builds and all the logs of our deployments. And it's live, and you can see that sometimes we've got red builds because one test didn't go well. But it's totally transparent, really. And the 100 deployments I told you about earlier, that information I got from Travis. So I just went to the page and looked at how many deployments we did in the last 3 months. So all public. Yep.
You mentioned Sagan as a reference app. You know, if I go back to the office and I do a presentation, what are actually anti-patterns for Sagan? What would be a worst case or a bad use case for Sagan?
So the question is, what would be, Sagan is a reference app, but what would be a bad use case for Sagan? Yeah, where is that approach inappropriate? So Sagan is, I'd say the public face of Sagan is not using sessions, because you don't have to log in Spring.io website. So that if you some of the things we're doing may not be good. But at the same time, we do have an admin for Sagan. If you run it locally, if you run Sagan locally, if you go to spring.io/admin, you won't be able to access that. But there's a login with GitHub button, and we log in into the admin part of Sagan using GitHub OAuth, the OAuth endpoint. So there's an example of OAuth, GitHub integration, and admin. So that's that's a good thing, because we didn't want to manage yet another list of users that should be accessing that. Whenever one user is accessing as the commit rights to the Spring projects, then it's automatically done. You can write blog posts into the Spring.io website. That's how we do. That's why we do it. But yeah, besides that, yeah, for example, some of the patterns wouldn't be probably good if you were trying to do e-commerce or something like this, because we're not relying a lot on sessions. But yeah, that would be one, I'd say. But other than that, I think it's a pretty good examples of a website with a public face and also an admin part, and using a lot of external systems and running it into the cloud. So the problems I showed you, I think one thing, I mean, on-premise or in the cloud with a lot of external systems, and if you're trying to, I don't know, use your resources efficiently. So that's one good example, I think, for that. Yeah?
So are you using the Alliance, the Pro enterprise version of the new Relic?
I think all I showed you was probably the regular, the first version you get whenever you subscribe to the product on the marketplace, and so all that I showed was that version, and but I did send an email to the New Relic people, and I'm trying to test other things. I didn't, for example, there's a feature, I think that's one feature with the Pro, probably, account, where you can add client libraries into your web app and have metrics for browsers, how's the web performance going on the client side. So that part I didn't use yet, so I didn't show it, but I think it's in the Pro version. Oh, the question was, did the use of boot make things more? I mean, made things easier or harder to use with the New Relic dashboard? So I don't think it made things. It was really transparent, I think. Looking at the dashboard, I don't think you can say that if the application is using boot or not. It's just showing the controllers and actions and endpoints. And it's quite transparent on that side. So it's not, I'd say it's transparent. OK. So thanks a lot.